here we go. All right, so what you need to have in front of you is your models of chemical reaction classifications. So you need to have this foldable. We made this foldable. And if you haven't printed it out, it would be a good idea that you go ahead and do that. This is a very powerful tool for predicting products. Okay, so I want you to have this handy. And then I want you to have your textbook. Somebody made a good point. Well, Mr. A, what if I have to turn in my textbook? There is an online version of your textbook, and I posted a link to that again today. And the other thing that you can do is you can make copies. You can make copies of the tables in your from your textbook that you will need. So, for example, page 616 is where you will find, I believe, this one. Yes. So this is figure 16 on page 616.
So wait, what if we don't turn in our textbooks this year? What we have to?
You owe me $50. You owe Miss Cash $50.
So we can't turn them in next year?
You'll have to take that up with her. Page 616. I only have so many of these textbooks, and if you guys take them, it's like I can't get any more textbooks. Okay, so page 616 is the table where this kind of scrunched up periodic table where you've got the oxidation numbers. You're going to need that. On page 619, you've got your polyatomic ions. On page 619, you're going to need that. And then prefixes is on page 621. So this is an open book, open note test. So you're going to need them. And then I skipped one. Back up. This is also on page 616. Page 616. Okay, so what I did was I copy and pasted and blew these up really big so I can use them today. And, you know, it wouldn't hurt to have a copy of a full-size periodic table, but also this is the one that's in the back cover of your textbook, right? That big one. Okay, so let's see what a couple of these programs, a couple of these questions are going to look like. Now, I am going to use the problems from the additional practice that I posted in the Google Classroom last week on the 15th of May. And there were some problems, number 13 through 18, which were the type of, exactly this type of word problems that are going to be on your final exam. So, for example, this one is number 13 from that additional practice page. Okay, so number 13 says liquid metal reacts with liquid bromine. Okay, so what you're going to do is you are going to write a full-blown chemical reaction equation based only on the word description of the products. Okay, so what are the products here? Well, obviously we've got some lithium, and that is going to react with, that means a plus sign. So lithium reacts with liquid bromine, and so here's the chemical symbol for bromine. Now, this isn't a complete symbolic description of the products because we need some additional things. First of all, you need to recognize that liquid bromine is diatomic, meaning I have to put a little subscript here. Now, what does that mean, Mr. A? Diatomic. Well, di means two and atomic means two atoms. So for every molecule of liquid bromine, there are two bromine atoms. Now there are seven diatomic elements, and you should have watched Tyler DeWitt's video on common mistakes, diatomic elements. You can go back and find that in the stream. But basically, he tells you what diatomic elements are and how you need to handle them in a chemical reaction equation. Now, this is something that Tyler DeWitt won't tell you, how to memorize them. This is how I memorize them. Have no fear of ice cold beer. Wait, what? What did you say, Mr. A? I said, have no fear of ice cold beer. Well, Mr. A, why are you saying such random things? Okay. Have no fear of ice cold beer. Okay. These are the 7 diatomic elements, meaning that you never see an atom of hydrogen just floating around all of it by itself. It's always got a buddy. So does nitrogen, so does fluorine, so does oxygen, O2. You've heard oxygen described as O2 before. Iodine, I2, chlorine gas, and Br. So whenever you see a Br, oh, Br needs a buddy, right? Now, when Br is in a compound, as we'll see in just a minute, we don't necessarily have that 2 there, right? Because this is only to form the neutral compound. And for that to happen with liquid bromine, we know bromine is diatomic, so we have to have a 2 there. Okay, anyway, that's just one of the things to keep an eye out for, is your diatomics, okay? Now, the other thing that you need to know is on that table on page 535, where is it? Hang on. I gotta get it. Okay. Page 535, there's this table of additional symbols used in chemical equations. All right. Now, we know that this plus sign means reacts with, and we know that the arrow means that yields or produces, but you may have seen some other symbols that I call the states of matter. So when you see liquid bromine, you need to put as a subscript little lowercase script L. That means liquid. So liquid bromine is reacting with metal lithium. So if lithium is in the metal form, then we know it's a solid. So when I say that you have to write a complete chemical equation, complete with states of matter, these are these little subscripts, these solid, liquid, gas, and aqueous solutions symbols that you put near each term of the equation, okay? All right, so this is in symbols what I wrote in words. Now the predicting part comes in, okay? So now you need your handy-dandy models, and you look at this and you say, which one does this look like? Anybody? Can anybody out there tell me? First one, second one, third one, fourth one, fifth one.
One of the 5.
Yep.
4.
Nope.
First one.
First one. Exactly right. Right.
That.
So
I wanted to let someone have a moment to shine.
we know that lithium is a thing, and so in our model, that thing is represented as a B, and we know that bromine is a thing, and we represent that thing as a B, and the model shows us that if it's an A plus B type reaction, then that's what we call, flip open the door, a synthesis reaction, where one thing plus another thing equals a new thing, a compound of A and B, right? So this is like your secret decoder ring, right? Every time you see an A, you write lithium, and every time you see a B, you write bromine, okay? So lithium and bromine are going to react together to form what? What's the name of that compound?
Lithium bromoxide.
Bromide, lithium bromide, right? Don't make it too complicated. Just say it. Okay. So yes, it is going to create lithium bromide. Now, there's one more thing, or a couple more things that we need to check. First of all, is LIBR a thing? I mean, lithium bromide sounds like a thing, but in symbols, is this right? So what I
No.
mean by that is you have to make sure that you have correctly formed a neutral compound. Now, listen, I'm giving you all these steps. All of these steps to solving these problems are listed in your study guide. So maybe I should have told you at the beginning when I told you to have all this stuff out here in front of you, that you need to have your study guide too, because it tells you step by step that the next step after you use your model to predict the products, you have to make sure that you're forming a neutral compound. So to do that, you need your sheet with all the oxidation numbers on it, all right? Lithium is a group 1 element, so you know that it's a 1+ oxidation number, and bromine is a 1- oxidation number. Did you hear that? Did you hear that? Da 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 da. Wedding music. This is a match made in heaven right here, right? Lithium and bromine, their oxidation numbers automatically cancel out, so I don't have to put any subscripts here. It's LIBR. Okay? Now, one of the last steps, I forget what all the steps are, but one of the steps is after you form a neutral compound for all of your products, you need to balance the chemical equation. And we spent a couple of lessons on balancing. So let's check. Maybe it's already in balance. I don't know. Okay. Got one lithium over here. I got one lithium over there. Hey, not too bad so far, right? I got 2 bromines right here, right? I only got one bromine over here.
Mr.
So
A.
Yeah, it's not in balance. Yes.
So wait, what happened to the? So it's Li plus Br2, right? What
No. Yeah. So good point. You don't carry this 2 over. Remember, the subscripts are used to form neutral molecules or neutral compounds. And separately, the bromine needed to have a 2 here because it's diatomic. Elemental lithium in the solid form didn't need any subscripts. Over here, we had to check and see if we needed subscripts over here. But because their oxidation numbers canceled each other out, they don't need any subscripts. So remember, subscripts are used to form neutral compounds. They are not used in balancing the chemical equation. So for the same reason that you don't copy it over, you can't add it here. Because remember, when you did the upside down t-chart, you went to a lot of trouble to make sure that you knew exactly how many of each particle were present in the compound. If you write a 2 here, it's no longer lithium bromide anymore. It's something else, right? So you can't do that. You can't add subscripts, but you can add coefficients. So you say, well, all I need to do is add a 2 right here, and that multiplies everything. It multiplies the lithium and the bromine. So now I just balance my bromines. But you just threw your lithium out of whack because you got 2 lithium over here and only 1 lithium over here. Hey, easy peasy solution. Since lithium's all by itself over here, you just add a 2 right here. Okay? So this is, if you got this particular question for the final exam, this would be your answer. All right? A complete chemical reaction equation, including the prediction of the products, the balanced equation, classification, all that kind of stuff. Okay, so this is what I'm asking for. That one took a while. Let me do another one. This, by the way, was a synthesis reaction. That's what it told us in our foldable. Okay, all right. So let's do another one. I want to do I want to do a single replacement reaction if I can find it. Yeah, this works. Number 14 is the next one. All right, so it says potassium metal reacts with silver chloride. Okay, that's all I'm going to give you for your one word problem. Okay, we recognize this word as being this symbol. By the way, this is elemental potassium in the metal state, so we can go ahead and write parenthesis S as it being in the solid form. Reacts with, we know that phrase to mean the plus sign in the equation. And then silver chloride, silver chloride, silver chloride. That is not just one thing, but that's a couple of things, isn't it? Right? If we looked up on our periodic table, we would see that silver is Ag, and chloride, you can't find chloride on the periodic table, but you can find chlorine, Cl. Okay, so you have changed the words into symbols. Let's make sure that you have the compounds formed correctly for the products. Here's a compound. Is it formed correctly? Yes or no? You guys are having a hard time remembering back to March or February when we were in our unit on nomenclature and we were writing the names and formulas for chemical compounds. You remember that you have to look up the oxidation numbers. Chlorine, we know, of course, is a -1. Silver, oh my, is silver one of our special ones? Well, it's not on our list, right? Silver has an oxidation number of a 2+. Okay? The way you know that is I'd probably have to tell you that. So the best way for me to tell you that is in the problem description, and it would have to be silver 2 chloride. Okay, maybe that's why I was hearing the sound of crickets, because everybody was going, oh, Mr. A, is that silver 2 chloride or silver 3 chloride? Okay, so I messed up and didn't put the Roman numeral there in the silver. Okay, so we're told that it's silver 2 chloride. So silver has an oxidation number of 2, chlorine has an oxidation number of -1. So I'm going to, what? I'm going to need 2 chlorines to go with every silver, which means I'm just going to put a subscript right here. Okay, so that's the proper formation of the compound silver chloride. Okay, and it is going to react with and form some products. In order to predict what those products are, again, you're going to refer to your model. And which one do you think that's going to be? Mr. A, you're pointing right at it. Right. You even
that one.
Yes, that one. That one. Yes.
Yay.
I even said at the beginning I wanted to do an example of a single displacement, single replacement reaction. Okay? And that is the case where the lone metal is going to kick out the metal in this binary ionic compound here. So potassium is going to kick silver out. Okay? That's what's happened chemical-wise. Now, if you look at your model, it's kind of switchy around here. The model actually writes it a little bit different, but just like some property of mathematics, which means that you can move things around without disturbing them, same thing applies here. Okay, so potassium is represented by C, or maybe I should say it the other way. C is represented by potassium, A is represented by silver, B is represented by chlorine. So if this model says in this case, then what you're going to get on this side is a CB plus A. Okay? So every time you see a C, you write a K. Every time you see a B, you write a CL. And every time you see an A, you write an AG. Okay? So that's how you use your model to write your products. Okay. We need to make sure potassium chloride is, that we form that compound correctly. So potassium is a 1 plus and chlorine is a 1 minus. Da, 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 da. Match made in heaven. We don't have to write any subscripts there. And in elemental silver, we don't need to write any subscripts there, except for the fact that if we see silver all by itself, it's not diatomic, so we don't need any subscripts there, but it will be represented in the silver, in the solid form there. Okay. To balance this chemical equation, 1 potassium here, 1 potassium here, 1 silver here, 1 silver here, 2 chlorine here, 1 chlorine here. So I need to put a coefficient of 2. I know I'm not drawing the line and doing the dit dot, dit dot, dit dot. If you need to use that strategy, you can. Okay, so I balanced my chlorines, but I threw off my potassium. No problem. I can just put a 2 right there for my potassium, and everything else is honky-dory. So I balanced the chemical equation. I'm not going to hold you accountable for this because we didn't have time to do this during regularly scheduled class. I mean, traditional school where we could go into a laboratory and I would show you, I would actually drop a chunk of potassium in this aqueous solution of silver chloride. What it would produce would be an aqueous solution of potassium chloride, and solid silver would precipitate out. And in fact, one of the assignments that I have students traditionally do is to look up this reaction on YouTube. You can look up any reaction on YouTube, and you will actually see a guy dropping a chunk of potassium in a clear solution, and then the clear solution all of a sudden precipitates out this silver. And it's like, whoa, you mean this chemical reaction like produces silver? It's like magic. It's like, pow, I could get rich. Can we do this with gold, right? No. The silver was always present in solution. It's just the potassium kicked it out and caused silver metal to form in the bottom of the test tube. So it's not like any magic or anything like that. It's chemistry, right? But you can see how the old timies were confused about that kind of stuff because they really thought they had something going on. No. This is a very expensive solution right here because it got silver in it. Okay. Anyway, I'm not going to hold you responsible for what an aqueous solution is. If you Google the reaction and you see that it's supposed to be aqueous, I'm not going to count you off if you put it on there. But I do expect for, if I say metal, you need to write solid. If I say liquid bromine, then you need to write liquid, right? So if I give you the word in the word problem, it needs to show up in this problem statement. But since I didn't say an aqueous solution of silver chloride, you don't have to write aqueous here. But if I do write aqueous solution of silver chloride, then you do have to write it here. Okay, so remember, really what you're doing is you are interpreting, just like this is some kind of a foreign language, right? You're interpreting these words into symbols, okay? Then you're doing the predicting, then you're forming the compounds, the neutral compounds, by paying attention to oxidation numbers and writing the proper subscripts. Then you're balancing the chemical equation, and then you check to make sure that if you have any clues for what the states of matter are, that you're including them too, okay? Again, this is all explained on the study guide. All right, I have time for about one more. And so again, I'm getting all of these examples. from the practice page I posted on the 15th of May. So sodium metal. No, that's another single replacement. This is going to be a hard one. Oh, I could do this one. Oh gosh, that's ugly. All right, let's do this. A solution of 10,2 nitrate and potassium hydroxide. Yuck. Okay, a solution of tin nitrate and potassium hydroxide. Okay, real quick. Tin, the chemical symbol for tin is SN. And nitrate, you're going to need your polyatomic ions. So you pull out that sheet. Nitrate is a NO3. And potassium hydroxide, that's going to be K. And the hydroxide polyatomic ion is an OH. Okay, so those are the symbols for the elements mentioned there. This is telling me it's a solution, so aqueous solution. I assume that this is an aqueous solution also. The oxidation number for tin is, they tell you it's 10,2, so that's a 2 minus. And the oxidation number for a nitrate is a 1 minus. So in that case, you would have to have 2 nitrate particles for every tin particle. Okay? So in this case, you'd have to write that 2 right there. Now then, KOH, the oxidation number for potassium is a 1 plus, and the oxidation number for the polyatomic hydroxide ion is a 1 minus. Da-da-da-da, match made in heavens, those two cancel out. I don't need any subscripts there. This is the proper formation of the products. Now we need to do some prediction. All right? So what does that one look like? You're pointing to it, Mr. A. Yes, this is a double replacement, the old switcheroo, the swingers reaction, right? So in this case, A is represented by 10, B is represented by the nitrate particle, C is represented by potassium, D is represented by the hydroxide ion. And if you follow your model, what's going to happen is that instead of A, B, C, D, what you're going to get is AD plus CB. So every time you see an A, you write an SN. Every time you see a D, you write an OH. Every time you see a C, you write a K. Every time you see a B, you're going to write an NO3. All right, I'm running out of space here. Plus K NO3. Okay? Now you need to make sure that you form the proper that you form the compounds properly and form neutral compounds. 10 was a 10,2, 2 minus. OH was a 1 minus. So you know you're going to need 2 OHs to go with every 10. And potassium nitrate, the nitrate ion is a 1 minus, and potassium is a 1 plus. Da-da-da-da. You don't need to have any more subscripts there. Okay? And then what you're going to get, no penalty if you don't write this, but I'll just tell you that you're going to get a couple of aqueous solutions when this reaction happens and go forward. What do we need to balance this? Okay, so I got 110 over here and 110 over here. I got 2 NO3 on this side. I'm going to have to squeeze in a 2 right here. 2 NO3 So that makes it a 2K. And I think if I put a 2 right here, then that balances out. Okay, so you have to balance the chemical equations. Sorry for squeezing that in. 2KNO3 plus 2KNO3. Okay, that was a whopper. Let's hope you don't get that one, right? So you will be assigned randomly. So chances are you could get one of these. Chances are you might get lucky, right? All right. So that was some examples of the types of problems that you're going to get on the final exam. Any questions?